Good morning, Tehmina Khan is here in TKMaths is Fun. In today's video, we will solve a question on momentum and it is taken from June 20, right? So the question is in front of you and it looks very long. So we'll break it up in two parts. There are three parts, so just focus on the first part. And I would suggest that you always make a rough sketch which will help you to understand the question better. So I have highlighted here important points. We are talking about here two spheres, A and B. They have equal radii and masses are different. So saying equal radii, I mean they have the same size when you look at it, right? And the masses are 4 kg and 2 kg. They are on the smooth plane, so we are not talking about here friction. Initially B is at rest, so velocity of B is 0 and A is moving towards B with this speed. You have to find out, okay, one more thing. After the spheres collide, A continues to move in the same direction. Okay, so I have explained this situation with the help of this diagram. So you can see particle A and B. Let me draw particle A, for example, with some other color. Okay, so mass and velocity I have written here and B is at 0. So find the speed of B after the collision. This is part A. So I'm applying the concept of law of conservation of momentum on A and B. And what does this say? Okay, before collision and after collision, the momentum of the system remains the same. Now what is momentum? Mass into velocity. Okay, so now before collision, if you see, I am talking about particle A and particle B. So I have written mass A times velocity A, mass B times velocity B, right? These are the abbreviation you can use. So I will simply substitute the values here. This is about A, so I will substitute in A, and this is about B, so I will substitute here. And the question told us here, okay, what happened after the collision. If you read this line, the particle A moves in the same direction, right? It will keep moving forward, but speed will be half of particle B. Okay, so now that's why I have written here for A, I have written velocity of B divided by 2. Okay, so you can use any of these depending you want to make changes here or here, but it will come into same letter then. So I change it into velocity of B. Reason is I have to find out in the question speed of B after the collision. Okay, so now I will simply plug in the values here and try to solve it, right? All the values are given here. So I have simply plugged in the values and I'm solving it like algebra. And I got the value here. The velocity of B is 10 meter per second. Okay, and velocity A will be half of it, so it will be 5 meter per second. So this is how you will find out the velocity. Now let's come to part B. Achha, by the way, I solved this in advance. The reason is I use different colors to highlight the importance. So if I use different colors and write it at the same time while I'm making video, it will take too long. So I try to make video shorter because simple calculation at this stage, I believe every student know. Plus, minus, division, all these sort of things. Okay, so now it is about part B. A third is small, smooth sphere, and it also has the same radii, right? It has mass 1 kg, and it is at rest on plane B. Now, what actually has happened? Particle A was here, B was here. A hits B, B start moving with the speed of 10 meter per second. You can see here. And A is also moving here but with slower speed, 5 meter per second. And particle C is here somewhere. You can see it is saying it is on rest and B now collides directly with C. It means C is ahead of it and it is at 0 speed here, rest. So now this particle B will collide here. So I have here drawn the diagram to make you understand everything. Okay. So now what you have to show here, you have to show that there will be another collision between A and B. That is only possible when B hits C and speed slows down, right? Because it is written here, after the collision, B continues to move in the same direction. So when B is hitting C, C will start moving, but B is also moving here. So if you have to prove that A will collide, which is coming behind it, that is only possible that the speed of B, which is 10 meter per second, slows down. Slower than what? Because velocity of A after the hit was 5 meter per second. We have calculated it here. So when B will hit C, if the speed slower than 5 meter per second, then it is understood that A and B will collide again. So this is what we have to prove here, right? So when question comes, you have to understand what is required and how you can prove it. Okay, so now I'm just cleaning up the place a bit. So now let's see what I will do. I will apply law of conservation of momentum on what? B and C now. Okay, because the only thing I want to see, what will be the speed of B after the collision. Okay, so this is the new situation I have put here for B and C, and I am going to apply here law of conservation of momentum before and after the collision. So this is before collision about B and C information, which is written here, and this will be after the collision. Now what was given in the question? If you see, okay. So I'm substituting the values here. Okay. This was given to here that the velocity of B will be 1/3 of velocity of C. It was written here in the question in this line. This is what I was talking about here. B continues to move in the same direction, but 1/3 of the speed of C. Okay, so whatever will be the speed of C, we will divide it by 3 to get the velocity of B. Okay, so now because of this reason, I have written here the velocity for C is 3 times of VB. I could also write here, instead of VB, I could write here VC divided by 3, my choice. Okay, so that will help me to get the velocity of B, because I have to check the velocity of B. So when I calculated, I found that the velocity of B is coming 4 meter per second, right? What it is coming? 4 meter per second. And what was the velocity of A after the collision? 5 meter per second. So now A is coming with the speed of 5, and after the collision, B is moving with the speed of 4 meter per second. So definitely after some time, A will hit it. Agreed? So but after getting this, you could write in a statement here that since velocity of A is bigger than velocity of B, hence there will be another collision. And this was the question between A and B. What is part C? This is very interesting. So we are going to apply here the concept of kinetic energy also in this question. So the last part of the question is asking or telling you that A and B coalesces during the collision. So now when this A will hit B, what will happen? They will combine. They will become one body. Okay. And then they will move, or whatever they do. Question here is find the total loss of kinetic energy in the system. So let me just put the situation up here one more time so that you can understand it better. In the first stage, A started with velocity 10, because kinetic energy depends on what? Velocity, right? Half mv square. This is the formula. So when the whole experiment or whole situation occurred, initially the velocity of particle A was 10. Now I will see in the last stage what is the velocity of the particle. That will help me to calculate the loss in kinetic energy. So in the last stage, when A hits B, right, they became together. I don't know their velocity. What was it? I will calculate that. And some of the energy was already transferred in C also, because now C has started moving with velocity 12. Okay. So now what is the velocity of A and B together? Now see here. How we will calculate it? Yes, you are right. We will calculate it with the help of law of conservation of momentum. So before collision and after the collision for A and B, I'm going to substitute here the values. I have put the situation here for you. Can you see what I have written here after the collision? Because it was written, they will become one body. A and B will combine, coalesce. Okay, so now I'm plugging in the values here to find the velocity of particles when they are together. So it was 14 divided by 3 meter per second. So this is the velocity of the particle A and B. Now I have velocity of all the particles at different stages. A initially, when A and B combined, and then C. So because question is saying find the total loss of kinetic energy in the system due to 3 collisions. So I will do stepwise. So first kinetic energy is of particle A, which is 200 square meter. Then it is what? Okay, this is I just tried to explain again, so you don't need to focus on this. I have already explained it to you. So now this is the velocity of A and B together, 196 divided by 3. I have written the whole number as it is so that we can get the last answer accurate. And the particle of C, what is this? 72 joules, right? The unit of kinetic energy or any energy is joules and joules. People pronounce it differently. So it is 72 joules. So now I have the kinetic energy of stage 1 and then in the last stage. So from the total one, I will subtract 200 minus 196.3 because this is the energy which is transferring continuously. So these two energies were transferred. So from the initial energy, I'm subtracting them to get the loss in kinetic energy. So I hope you understood it. Thank you very much for watching it. Please press like and subscribe button, and you can give comments as well if any clarification is required. Take care. Allah Hafiz.